Welcome back to math. All right, so today we're going to add to our knowledge from the other day. First off, we're going to do some more classifying, all right? Remember we talked about classifying by sides, we talked about classifying by angles, all right? And we are going to mix that today, all right? What I mean by that is that this is an equilateral triangle, but it's also acute. It's equilateral because it's got three sides the same. It's acute because all the angles are acute. So we can give it both names at the same time. We can get one name from each column. Let's come over here. Hold on. There we go. This is a right triangle because it has a right angle. It's also scalene because none of the sides are the same. We can get one name from each column, and that's true for every triangle. All right? We can name it in two ways. We're going to do that today. A couple things. I took angle measures off here, and I drew this little arc right here. They oftentimes use that arc to signify an obtuse angle. So if there's nothing on there, it's acute. If there's the box, it's right. But if they use this little curve, sometimes that means it's obtuse. That's what it's going to mean today. All right? And then we're going to do a little bit more of this. Do the angles add up to 180? Super easy. And we're going to do a little more of this. Can we find a missing angle? But now let's learn something. My hair looks good today, doesn't it? All right, so first things first, I need you to copy this board down. All right, now hit pause. Okay, that's the only thing I'm gonna have you copy down, all right? Well, actually, I'm gonna have you copy the other one down, but not from the video. So I'm gonna work this from right here, all right? And then I'm gonna go over to the other screen and I'm gonna have you watch me, all right? So what are we doing today? We are drawing a triangle from three sides. There's two skills we're gonna do here. They're both kind of simple, all right? But very specific. The first skill when we draw a triangle from three sides is I'm gonna give you three numbers, all right? And I'm gonna say, we're gonna draw that triangle. First things first, step one, do they even make a triangle? Not all three lines make a triangle, all right? You can tell that from this right here. These aren't gonna make a triangle. They don't reach, right? These make a triangle. Beautiful. These don't. All right, so not all three lines make a triangle. Example, step one. In order to figure out whether they make a triangle or not, we add the two short sides. They must be more than the third side. So right here, we have three numbers. Do they make a triangle? Yes, they do. Because the two short sides, 4 plus 5 equal 9, and 9 is more than 8. Lovely. Let's come over here and look at one that doesn't make a triangle. All right? If it was 8, 5, and 2, it does not make a triangle. Why? Because add the two short sides, 2 plus 5 equals 7. 7 is less than 8. All right? And it's like my example. I'm going to come over here with the ruler and the two sticks right here. They don't reach. Just look at that little drawing right over there and imagine that red line and that green line don't reach. They don't have enough to span the bridge or whatever, all right? So if those two short sides added together don't get bigger than the long side, you don't have a triangle. So that's step one. Do we even have a triangle? Sometimes we do and sometimes we don't. If we don't have a triangle, we just stop, move on. But if we do have a triangle, if we don't have a triangle, we stop and we're done with the problem. If we do have a triangle, now we have one more thing to do. All right? So step one, do we even have a triangle? Simple little test. Step two, let's go to the other board. All right, there we go. Step two, we're going to use the Pythagorean theorem to determine what type of angles our triangle has. Sounds complicated, but it's not. All right? So here are the three parts of step two. We're going to use the Pythagorean theorem to determine what kind of angles the triangle has. We're going to take the sides in order and call them A, B, and C. I'm working with example 1 over there. All right? It's in red. All right? Remember, example 2, there was nothing else to do. It was not a triangle. I'm working with example 1. You can't see it, but there are three sides, 8, 5, and 4. Look at your notes. So we're going to put them in order and call them A, B, and C. A is 4, B is 5, C is 8. Then we're going to square them. What does square mean? Remember, it means the number times itself. So 4 squared is 16, 5 squared is 25, 8 squared is 64. Then we're going to add a squared plus b squared. This should sound kind of like the Pythagorean theorem to you. We're going to add a squared plus b squared. In our case, 16 plus 25 makes 41. And now we come over here to the pink. Come over here. There are three options. All right? You have three options. Either this number you got right here, a squared plus b squared, if it equals c squared, or this number you got right here, a squared plus b squared, it's less than c squared, or this number you got right here, a squared plus b squared, is more than c squared. All right? You have two numbers, this number and that number. They're either equal, less than, or greater. Those are the three options. If they're equal, you have a right triangle. If a squared plus b squared is less than c squared, you have an obtuse triangle. And if a squared plus b squared is more than c squared, you have an acute triangle. All right, we're going to do examples of all these. So if this sounds overwhelming, it's really not. Again, take the numbers, square them, add two of them up. They're either equal, less than, or greater. Those are the only three options. All right? Because our a squared plus b squared, our 41, is less than our 64, all right, we have an obtuse triangle. Great. So now, from step one, we know we have a triangle. From step two, we know it's an obtuse triangle. So now, we also know it's scalene. Why? Well, because all three sides are different, right? 4, 5, and 8 were different from the jump. So it was scalene. So we have a scalene triangle that's also obtuse, and we can draw it something like this. Doesn't look exactly like that, but something like that. All right? We have an 8, we have a 4, and a 5. All three sides are different, and we have that obtuse angle up there. So we drew a triangle from three sides. Let's do one more example, except I'm going to do it in fast forward, all right? Because I'm going to just do all the math and fast forward, and then we'll catch back up at the big end when I draw the triangle. So Mr. Wamsted says, click the fast forward now. I said I was going to fast forward through this part, but I'm just going to talk fast, all right? So we have an 8, 5, and let's just change this to a 7, all right? Instead of a 4, let's say it's a 7. We still have a triangle because remember, you add the two small numbers together, and as long as that's bigger than the third number, checks out. You got a triangle. Let's come over here. All right, where we have 8, 5, 7. All right, remember we put them in order, A, B, C. So instead of 8, 5, 7 is it's 5, 7, 8, because they have to go in order. We square them. A squared is 25, B squared is 49, C squared is 64, and then we add up A squared plus B squared, all right? And so it's 25 plus 49. 25 plus 49 is 74. All right? So now when we come over here, a squared plus b squared is more than c squared. It's different than our other example. 74 is greater than 64. All right? A squared plus b squared is more than c squared, and so we have an acute triangle. A squared plus b squared is more than c squared, so we have an acute triangle. It's still scalene, but now it's acute. It was obtuse because this number wasn't big enough, but now it's big enough, so it's acute. All right? And so it doesn't change much about it. Instead of drawing that obtuse triangle, I'm just going to draw an acute triangle, try to draw it scalene. Watch. That's not great, but it's good enough, all right? I could do a third example. I'm not going to. I could do a third example where a squared plus b squared adds up to be exactly c squared, all right? And then we would have had a right triangle. That is what we're doing today, all right? So we've got classifying triangles. We have acute, obtuse, scalene, isosceles. We've got, is it a triangle from an angle point of view? Do they equal 180? We've got find a missing angle. And then we've got this, I'm going to give you three sides. All right, let me come back over here. Or let me just scoot back. Let me see if I can scoot back and get the whole thing. Oh, beautiful. Beautiful, Wamsted. We've got this, which is kind of a lot, all right? We've got this, where I'm going to give you three sides, and then you're going to test it to make sure it's a triangle, and then you're going to also use the Pythagorean theorem to determine whether it's acute, obtuse, or right, and then you're also going to draw the triangle. It's not bad, though, once you get into it. I'll walk you step by step through it. All right? What you're going to do now, and I'm going to switch to my my board, but you're going to copy this second half down, but not this half, the other half that was from before. You'll see it, all right? So y'all stop the video, go to that thing, copy the second half of the notes down, and I will see y'all later.